Okay, grade 12s. Here is a video on optimization. This is our favorite topic of grade 12. I'm kidding. But anyway, we're going to tackle this question and see how it goes in the process. So basically, this is a question from last year's National Senior Certificate. I think this is rather a lenient type of question, but somehow I feel there's still people that really want to, or students that really want to know how to go about solving this. And I'm going to give you a step-by-step process on how to actually answer optimization questions. There are normally steps, and regularly they'll give us something like this. They'll say, prove that this area formula in terms of x is shown as follows over there. And then they say you must determine a variable, or the value of a variable, such that the total area of the page is either a minimum, which is in this question, or a maximum, in terms of mainly either, let's say, a parabola or a cubic function. That was not what I wanted to do, but a cubic, yeah, you get what I'm saying, a cubic function. There, something like that. Where this point over here is obviously going to be the minimum, and then this one would be the maximum because it's the highest point that we have on the graph over here, like the turning point, right? That's turning point 1, and then this would be a turning point 2, which is our minimum. Okay, so now that we have an idea of what optimization is exactly asking us, let's just look at this question over here. So question 9 says, the diagram below represents a printed poster. So they give us a printed poster, which is going to be this entire rectangle outside, right? That's what we are looking at. A rectangle ABCD is the part on which the text is printed. So this shaded area over here. This shaded area, ABCD, is 432 centimeters square. And AD is equal to X centimeters. Okay, so they're saying AD, which is basically this length over here, is X centimeters. ABCD is 4 centimeters from the left and right edges, so they're talking about this over here and this, and 3 centimeters from the top and the bottom of the page, so there. Okay, so what I want to do is I want to actually first read these two questions that we are going to be dealing with. So question 9.1 over here says, show that the total area of the page is given by, and then this. So we have a function in terms of x, and we can clearly see that we are talking about the area. And then we have 9.2, which says, determine the value of x such that the total area of the page is a minimum. So first of all, what I'm going to be doing is I'm going to be drawing this rectangle, or this shape. I'm going to draw a rough sketch of the shape, and then we are going to determine the dimensions one by one. That is what we are expected to do at first. Alright, so let's determine what we have at the moment. So this is a rough sketch over here of the diagram that was given in the question. So what we need to determine, first of all, is what we were given, right? We were given that this dimension of ABCD, the shaded rectangle, is C, centimeters, right? Okay, and then what we should remember is that in this question here, I'm just going to quickly scroll up, that this over here is going to be 3 centimeters, right? So what I'm going to be doing is I'm going to shift it all the way to the end over here where the main rectangle is, the exterior rectangle, such that it's in line with that. So I'm going to do that over here. So we know over here that this is going to be 3 centimeters, and then this over here is going to be 3 centimeters, because that was also given. And then we need to look at this side of the rectangle as well. We need to focus on the length. So we can actually name that this is going to be the breadth and this is going to be the length of the main rectangle. Okay, now we need to focus on our measurements over here, right? So we know that this length from this point to this point is going to be 4 centimeters. So that's what we're going to do. We're going to make sure that it's in line over here, and then we're going to draw a rough sketch. So it's going to be 4 centimeters here, and then it's going to be 4 centimeters over here. Alright, now what we need to do is we need to determine what on earth is this length over here. What is this length? and what is this length, so that we can actually find out what is the area of this main rectangle. So how are we going to do that? Let's just consider the following. Remember that if something is unknown to us, we can actually name it. Because we are very, very bold mathematicians, we can actually label them as variables. So let us actually just label this as, I've just remembered that we can't really label this one yet, right? Because we don't have enough information. We don't know what this is going to be. So, but what we do know is that this AD is equal to x. So which means, because that's equal to x, which is basically this same length over here, we can see we even made dotted lines to indicate that we are keeping it in line with the rest of the information. And we can see that this over here is basically here, which is the rest of the length of the rectangle. So what we can do is we need to actually determine what is going to be the length of this. So what we can do is we can combine everything together. On this side we can add everything, and then it will look like that. It will be 4 centimeters plus 4 centimeters. I'm just going to add the constants first, plus x centimeters, which will basically just give us, I'm just going to put it in from x first, x plus 8. Let's keep it as x plus 8 for now, so that our calculations will be easier. But if you wanted to keep the centimeters, you could even write it like this. Or you could even write the centimeters outside like this, x centimeters and 8 centimeters. But for mathematics, we are going to keep it as just x plus 8. Alright, so I've made a little bit of an adjustment here. Right here, I said that the length is equal to x plus 8. So that's what we have determined. Now we need to determine what is this going to be over here. But we first need to determine what is this unknown variable. So let's actually do this, right? We know that this variable is in line with that, AB, right? Or AD, if you will. Or sorry, DC, if you will. So we need to determine what is AB going to be equal to. And what information do we have in order to do that? We have this rectangle, ABCD, with the length of that one equal to x centimeters. So let us actually determine the area of this rectangle. But guess what? Remember, in the beginning, they said that the shaded area, ABCD, is 432 centimeters square. So we already know the area, so we can just write that down. So it's 432. I'm just going to have to double check there. Let's just say 432, I'm assuming it is still. Yes, 432 is equal to, and the length times the breadth, right? Okay, so let me first write it like this. The area of ABCD, remember your subscripts, is going to be equal to the length times the breadth. In this case, it's going to be AD multiplied by AB. Let's just do that. So we know what the length is. It is x centimeters. So we're going to say x multiplied by breadth, right? So we're gonna okay, let's keep this as breadth, right? Because we know that's the breadth of a rectangle. And we know it was 432, right? 432 centimeters squared, yes. So we knew the area already. And now we just need to, remember, we need to find out what is the breadth. That's exactly in line with our unknown variable. So we make the breadth the subject of the formula. So what we are going to do is we are going to divide both sides by x, such that these x's will cancel out, and then we will have b equals to 432 over x. Alright, now we have our unknown variable. In this case, it's going to be 432 over x centimeters. Okay, now we just need to combine these two together, and then we'll get the following. So I'm just going to erase this. If you just please feel free to pause the video. If you are maybe a little bit lost, then you can just go back and then get yourself found again. Okay, so we need to add all of these together. So we're going to get 3 centimeters plus another 3 centimeters plus 432 over x, where these two will add together. So this is centimeters, which is equal to, let's put this first. Remember, the one with the variable normally goes first. So it's going to be 432 over x plus 3, which is 6. You can even write it like this with the centimeters outside or the centimeters over here, right next to them. But once again, for our mathematical, with our mathematical substitution, I did not say that right, we are going to keep it as just the variable and the constant. So let me just write that down right now. Alright, now that we have determined the dimensions of the rectangle, of the outside rectangle in our case over here, we have it in terms of x. We have the breadth equal to 432 over x plus 6, which I've just written down from our previous calculation. And then we have the length, which is going to be equal to x plus 8. And we know that in a rectangle, this side is equal to this side. The opposite sides are equal in length, like that, and that side is equal to that side. Okay, now let's do the area of the rectangle, and we should know what to do here. So it's going to be the area of, let's just say the poster, I believe it was the poster, is equal to the length times the breadth, and now we just need to substitute. The length was x plus 8, if I can remember, yes, x plus 8, and the breadth was 432 over x plus b. So we are going to multiply these two brackets over here. 432 over x plus 6. Now we just need to do some simple FOIL method. So what we can do over here is we are going to multiply using the FOIL method. So we're going to multiply the x into that, which is going to be x multiplied by 432 over x, which is just going to give us 432 multiplied by x over x. And then we are going to, remember now there's only plus signs, so we don't really need to worry about any negative signs. So that's plus, and then our next one, which is going to be the outer, it's going to be x multiplied by 6, which is going to be 6x. And then we're going to multiply 8 by 432 over x, which is going to be positive 432 multiplied by 8 over x plus 6 times 8, which is these last ones over here. 6 times 8, which is equal to 48. Alright, now from this point over here, we are going to just simplify as much as we can. We can see that these x's can cancel out, and then we need to make sure that this is we need to multiply these two together. So we will get the following. We will get, so because those x's cancel out, we are left with a constant of 432 plus, and we have 6x over here. And then if we multiply these two together, we will get an answer. If we put it on the calculator, that answer will be 3,456. So it'll be plus 3,456 over here. And then this is over x. And then we have plus 48. Now we need to just add the like terms together. And remember that we need to show it in the form of this equation over here, which you can see we're getting close to that equation already. 3,456 as the numerator there. And then let's just do that basically. So we need to put the fraction first, which is going to be 3,456 over x plus 6x. And then if we add 432 by 48, then we are going to get an answer of 480. And that is going to be the area of the poster. Or actually, no, sorry. What I meant to do over here in the beginning was this was supposed to be a of x. So it's going to be a of x. That is going to be our function. Remember, that's what they asked in the beginning. So please make sure to pay attention there. You got the first-hand experience of what a silly little mistake is. So remember, you need to consider your variables and your functions over here for this question here. And then therefore, a of x is equal to this, which we have now proven. Now we need to go to the next question. And the next question, let's just be reminded what it says. Determine the value of x such that the total area of the page is a minimum. Okay, so whenever we want to determine with the maximum and the minimum, right, if you can remember, we would normally, first of all, find the first derivative. So let's say in this case it's going to be a prime of x, and then we are going to let a prime of x equal to 0. Now, why do we do that? Let's look at a visual representation on why exactly we do that. So let's consider this function over here, right? let's say that right now we have, in our case, let's say we have a parabola, right? And let's try and put a minimum in it. Let's involve a minimum, right? Because that's with our problem. And then we do the following over here. We can see that this is going to be our minimum. And if you can remember from your lessons, that your teacher would normally draw like a tangent line that touches this point right here. Only one point. Remember, it's a tangent line, so it only intersects with one point on a function. It's not a second, because a second will intersect with 2 points. So if we draw a tangent line, at the minimum, we will get a horizontal line. And what do we know about the horizontal line? The gradient will be equal to 0. And we have heard from the teachers, or the teachers have told us that we say that the first derivative of a function is going to be equal to the gradient. And because the gradient is equal to 0, that is why we let f of x equal to 0. And just to go a little bit further into the analysis, when we are letting f prime of x equal to 0, that is essentially finding the x-intercept of our first derivative function. And obviously, if we were to draw the derivative, remember, this is a parabola, and the derivative of a parabola, so parab, will be a straight line, right? So the derivative of a parabola is a straight line, and then we'll get some straight line, which it's the point. Remember, at the derivative of a constant will just be 0, so that is why the y value will be in line with this y equals 0, and then our depending on our a value, it will be a positive gradient, and that will now be our x-intercept. Alright, so now we need to determine the value of x. So in order to do that, once again, remember, we need to find the first derivative. But we can see over here that we can't really do that yet, because it's a little bit more complicated since we have x in the denominator. So we need to write it such that it's much more of a linear equation over here. So we have 3,456, and then we can write this as multiplied by x to the power of -1, according to your exponent laws. You should be very familiar with the exponent laws at this moment over here, and we're going to have plus 6x plus 480. Now we can differentiate. We can find the first derivative, and remember your power rule. Your power rule states that if you're taking the derivative of, let's say, x to the power of n, that will just give us a multiplied by n multiplied by the x over here to the power of n minus 1. So let's just do that exactly over here. That is our power rule. So I'm going to write here PR. Okay. Now we just need to find the first derivative. We need to find the first derivative, and then if we do that, we are going to have this. Remember, now we need to find the derivative of this first term, which is going to be 3,456 multiplied by the exponent, which is -1, which is just going to be negative 3,456 multiplied by x to the power of -1 minus 1, which is -2. And then we're going to have plus, and then the derivative of 6x, we're just going to see it as it's going to be 6 multiplied by 1, because you can see the exponent here is 1, which is going to give us 6. And then x to the power of 1 minus 1, I'm just going to write it there, is going to be 0. And anything to the power of 0 is just 1. So that's multiplied by 1, but we can just leave it as 6. And then the derivative of a constant is just going to be equal to 0. But we don't have to write that down. But I'll keep it there anyway. Okay, from this point, we have our first derivative. Now we let that equal to 0. And now we just need to solve for x at this point over here. So the first thing I actually want to do before we do that, I just want to write this as a fraction again. So it's going to be negative 3,456 over x squared, because now it's going to be a positive exponent. We're converting it due to the exponent laws. If I did say Newton's laws, I apologize. It happens. It's a prime of x, and then we're going to have this. Now we can just solve for x over here by letting it equal to 0. Sorry, over here. So let me do that. It's equal to 0. Okay, now we're going to minus both sides by 6, where these will cancel out. So negative 6 is on this side, and then we're going to have negative 3,456 over x squared. And this, remember, this is negative 6 over 1. With this, we can now cross multiply, and then we'll get the following. 1 multiplied by negative 3,456 is just negative 3,456. And that's equal to negative 6 multiplied by x squared, which is going to be negative 6x squared. Alright, now we can see that these negatives over here, they will cancel. And then we are left with 3,456 equals to 6x squared. And then we can divide both sides by 6. And then these 6's will cancel out. And then we are going to be left with, let me put x squared on the left hand side here. X squared equals to 3,456 divided by 6, which is just going to be 576. Now remember, we have to square root both sides. And if you can remember, whenever we have an even root, we will plus minus. But because we are determining x, and x is a side of the shape, we will always choose it as positive. Okay, so then these will cancel, and we'll get x on its own. And then the square root of 576, which I'm going to have over here, is going to be equal to 24 centimeters. And that is how we determine the value of x for which there is a minimum. And it was, yeah, such that the area of the page is a minimum.